Good morning, everyone. Today we discuss periodic trends part second. Till now it was part one. So I told in the beginning, in 11th class, we don't worry about the how the periodic table is made because this was there in 10th class. Therefore, straight away we went as a recap, as a revision. So after understanding how the modern periodic law and the modern periodic table is made by Moseley and his team, Henry Moseley and his team. Now, today we have to discuss what are trends on the modern periodic table. So, again, in the trends, there are two parts, part one, part two. So, in the previous session, maybe on Saturday, we completed periodic trends part one. Okay. Now, today we discuss uh, periodic trends part 2. In that, today's topic of discussion is the relation between annihilation enthalpy, electronic configuration, and atomic radius. Okay. All three are co-related. These three terms, they overlap. They are co-related. Nowadays, we study a correlation of subjects, what we say, no? So, for example, we study biology in chemistry under the heading biochemistry. We study microbes under the biology known as the microbiology. We study physics in chemistry, physical chemistry. Hmm? So we study mathematics in chemistry. It is known as mathematical chemistry under numerical chemistry. So all those, it is called correlation of subjects. One subject has got relation to the other on the other. So otherwise, one subject will make use in understanding, in analyzing the that subject like that. So here also the three phrases, the three words, annihilation enthalpy, electronic configuration, and atomic radius, all three are closely related. Okay. So now we discuss. Here I brought two important forces which are acting on outer electron. So the outer electron experiences two opposing forces. What is one? One is force of attraction from nucleus. The other one is force of repulsion from inner electrons. Okay. So two forces are acting on outer electrons. Okay. So out of the two, which force dominates on that ground? We have to discuss ionization enthalpy. Okay. That's why the third point is what? Third point is the decrease in the force of attraction exerted by the nucleus on the valency electrons due to the presence of electrons in the inner shells is called the screening effect or shielding effect. So shielding effect, already I told a small mental picture I brought how to understand the shielding effect. Example also I gave what is meant by shield. It is a kind of protection cover. Okay, so we wear sweater during the winter. So sweater acts as a shield for our body. So that is called shield. And what is shielding effect here? Shielding effect is excuse me. The inner electrons acts as shield for the outer electrons. Inner electrons, they cover the outer electrons. Why they cover? From what they cover? They cover from the nuclear force of attraction. Nucleus wants to attract the outer electrons, but it is the inner electrons. Okay, so to some extent, not fully, to some extent, they cover. So when they cover the outer electrons by the inner electrons, okay, that time nucleus will not have that much attractive force on the outer electrons or valence electrons. So we find there is a decrease in the attractive force between nucleus and the outer electrons because of what? Covering by inner electrons, and this effect is called what? A shielding effect. Okay, so the shield diagrammatically it is shown here on the extreme right side of the slide where we have the outer electrons. Okay, and these are inner electrons. These are inner electrons. Okay, so nucleus wants to attract this electron but due to the cover, they'll be moving here. They'll be moving continuously. So they'll be covering the outer electrons. So therefore, decrease in the attractive force is experienced by the outer electron from the nucleus. That's why we can take out electron easily. So all these, why you have to learn? Because what is our topic of discussion? Ionization enthalpy. What is ionization enthalpy? It is the energy required to remove the outer electron. So to remove outer electron, what are the factors? Okay. So on what ground the ionization enthalpy depends, so that we can easily take out the electron. The purpose is to take out the electron easily with the least effort, with the least physical labor, with the least amount of energy, so that we can save energy, because energy saving is very important. Let's not spend unnecessarily energy here. Okay, so that energy is required somewhere. Therefore, so to remove that electron, what are factors which are affecting on that electron, so that it can be removed with easily or with difficulty? That is the point of discussion. Okay, right. Now, next point. So this is what the screening effect increases if the number of electrons in the inner shells between the nucleus and the outermost electron increases. Definitely, definitely no. No, when few electrons are there, they can't cover properly. When more number of electrons are there, they cover properly. So more the number of electrons, which electrons? Inner electrons. Okay. More best is the cover, more best is the shielding, and more best is the shielding effect. Okay. And shielding is effective when the orbitals in the inner shells are completely filled. This is the most important factor. Okay. So inner electrons are there. But if the inner electrons are completely filled, for example, P6, D10, F14, so if this type of configuration is there, so inside the water, inside, so just before the outer electrons, then the shielding effect is very fantastic, more effective. Okay, so they do the fantastic job so that outer electrons are safe from the nucleus. So when the inner electrons are there, and if it is more, what is third one? More, that too with completely filled electronic configuration or completely filled orbitals, then we will have a beautiful shielding effect, or it is called what? Best shielding effect if the inner electrons are completely filled. And you have seen, see here, the order of screening effect. So S orbital is more than P, than D, than F. That means what? That means F orbitals are, if you see the shapes, they spread in the space, okay, in 3D, okay, 7 lobes. So it will not have that much shielding effect. So shielding effect is less with the F than the D, than the P, than the S. Okay, so it depends again what? It depends on the shape. S orbitals spends more time near the nucleus than the P, than the D, than the F. So depend upon the type of the electronic configuration or the type of the electrons. Okay, so we'll have shielding effect. Okay, right. Now, next is what? Next trend is electron gain enthalpy. After the ionization enthalpy, it is the electron gain enthalpy. So here, an atom is
Sir, one
gaining
more.
electron. An atom is gaining. Raghavendra, you want to ask something?
Yes, sir. Doubt, sir.
Please.
Sir, what is exactly definition of ionization enthalpy, sir?
Ionization enthalpy is the energy involved when we take out the most loosely bound electron from the atom. So to make it ion, it is an atom.
Yes, sir.
Hmm.
Sir,
When the,
in textbook it is given from atom in its isolated gaseous state, sir. I didn't understand this statement, sir.
so whenever present a scenario, I'll explain. Whenever a person gets the COVID 19 positive, he is isolated. He is quarantined. So one more equivalent word is isolated for the quarantine. So he is kept separate. You might have seen now in the hospitals they keep separate. Okay, only doctors are allowed to enter with that too with the precautions, with the special aprons, covers. Okay, all those kits are available now. So why? Because that is highly contagious, highly spreading. So even by air also nearby distance it spreads. So that's why it is called isolated. That means we have to take the atom to the isolated state. So normally atoms will be in the when the atom is in the gaseous state, not a problem at all. But if the atom is in the solid state, for example, metals, liquid state, mercury or the bromine, okay, then we have to take those elements to the gaseous state first. For that, you have to heat. So when we heat, so they go to the gaseous state, whether it is a liquid, whether it is solid or liquid. Because in the gaseous state, atoms are free to move. We can tackle easily. We can study easily because they will be moving here and there in the container. So that time, so we can think of separate electrons. In the solid state, it is a close packing. So atoms are closely packing. They have a definite shape, geometry. So that's that time each atom will be having interatomic attractions. So therefore, we have to supply a lot of energy. So that's why our first duty is what? To separate each individual atoms. That means take them to the gaseous state. This is called what? This is called enthalpy of sublimation. Whenever any atom is taken to the gaseous state, it is called enthalpy of vaporization or enthalpy of sublimation. Then that time you supply energy in a container. So individual atom will lose the electron. Okay, that is called what? Atom taking to the isolated state in the gaseous state, single atom is dealt separately, and that electron is knocked out from the orbital to convert into ion. That is called what? Isolated state of an atom, and that is the real energy we require to remove the electron, and that is calculated using some special techniques, and that is known as what? Ionization enthalpy in the isolated gaseous state. Okay, clear, Raghavendra?
Sir, the conclusion is that ionization enthalpy is amount of energy required to remove an electron from atom in its isolated gaseous state.
Definitely, definitely, definitely. Hmm?
Thank
Okay, okay. Okay, now we'll come to the point. So this is what? Electron gain enthalpy. To gain electron. To remove electron, we have supplied. Now we are adding electron. So already electrons are available. Okay, though it is a neutral, electrically neutral, but electrons are there. So adding electron to the existing system where electrons are there, so we face some certain problems because electron is going to the such area where already electronic cloud is there. So that means it is experiencing a kind of repulsion. Okay. So though the nucleus wants electron, it want to attract. So it want to attract, but other factors are there, no? So we want to go to someone's house, okay. But now Corona is there. So though they're ready to accept our arrival, but we only understand that now it is Corona, so let us not disturb them. So when the Corona subsides, then we will move, okay, to their houses. Now time being when the Corona becomes normal, so let us stay in our respective houses or respective homes. So this is a factor. Though they want to welcome, but we have to understand like that. Even in the electronic system also, electron wants to enter, nucleus wants to attract. But already existing electrons are there, no? So they will face some problems. So they will experience a certain amount of repulsive force. So because of this, electron is not added so easily. It is added. No doubt we add. Okay. So nowadays techniques are there, methods are there. So lot of energy is there. But with what ease? Okay, with what comfortability level we add electron, that matters. Okay, so ultimately we see the easy method or the shortcut method. So with the less amount of what I said, least in efforts. So all those factors are there, no? So that's why keeping all these factors, with what ease we add electron to the atom, that is called electron gain enthalpy. It is the energy change. It is the energy involvement when we add electron to the water neutral atom to make it anion, to make it negative ion. Okay, right. Now we'll come to the point given by the what textbook. It is the amount of energy released when electron is added. Okay, electron is, so I will remove this area, this side. So it is the amount of energy released when electron is added to outermost shell of an atom. See, it is added to the outermost. Electron not go inside because to go inside is very difficult. So outer area, if it is empty, if the provision is there, then we add. Okay, and if the need is there, first of all, if atom wants electron or not, that you have to check, you know. So if the atom is not requiring electron, then there is no meaning in adding. So please see the situation, demand, requirement, condition. Okay. So then only we go for adding of an electron. This energy release depends upon the extent of attraction for an incoming electron. See the extent of attraction. How far nucleus is required to attract electron. That is important. Okay. So in case of inert gases, they have almost no attraction because of stable configuration. So in the case of extreme right side group 18th, they don't want electron at all. Why you have to add? That means we face a lot of problem in the case of inert gases, noble gases are members of 18th group. So therefore, we face a tough situation to add electron. That's why whenever tough situation is there, we get what? We get what? There are some signs, a negative sign and the positive sign we use to denote or to represent the energy. Okay, if it is negative, energy is given out. If it is positive, energy is absorbed. Okay, so normally electron gain enthalpies are in positive. Okay, because we have to supply energy. Therefore, it is positive for inert gases. This means energy should be supplied in order to make them accept electron. So, lot of energy we have to supply to inert gases to make them negative, and so that's why we find whenever we see the data, electron gain enthalpy data, we see large value is there, large positive value for the inert gases because they don't want. If you force them, then you have to supply lot of energy. Yeah. Now factors affecting electron gain enthalpies. Atomic radius. More is the size, less is the nuclear charge, therefore less attraction for incoming electron, therefore electron gain enthalpy is less negative for those atoms. Okay. When the size is more, when the size is more, electron will have less attractive because we are adding electron to the distant orbital shell. Okay, so when the size is more, that means attractive force is less between the nucleus and the outer shell. That means what? Nucleus will not have that much attractive force to accept the electron. Okay, so that time we have to supply more energy. When the nucleus is having less power, less attractive force, then we only will add electron by supplying some energy. So that time it is also either less negative or more positive. That value you will see. Okay, right. Nuclear charge. Less is the nuclear charge, therefore less attraction for incoming electron, therefore electron gain enthalpy is less negative. When the nuclear charge is less, okay, so this will when you come to know when it is +1, +2, +3, there are some atoms they go for the +1 sodium, there are some atoms they go for the +2 magnesium, there are some atoms they go for the +3 aluminum, there are some atoms they will not go for the plus at all. Chlorine they will not go for a plus, it will go for negative. Okay, so that time whenever nuclear charge is less, okay, very less attractive force by the nucleus over the outer shell, then also we face a lot of problem to add electron. So that time we will have lot of energy to supply. That means the values of electron gain enthalpies are what? Are in the positive or less negative. So here positive, negative are no way connected with the mathematics. Don't think that in terms of mathematics this is a negative sign. Okay, there we add, they will separate. That is separate. Here negative, positive indicates evolution and absorption of energy. That's all. If minus is there, energy is given out. If plus is there, energy is taken. How much plus is there? How much minus is there? That is important here. Okay. Now electronic configuration. Atoms with stable electronic configurations have less negative electron gain enthalpy. Already electronic configuration is stable. Why they want? They don't want. I'm stable. I'm happy. I'm comfortable. Okay, so I don't want. So don't force me to accept electron. That time we have to supply more energy. Okay. So we will have electron gain enthalpy in the less negative. So less negative means what? For example, -10, -20 kilojoules mole. So -10 kilojoules mole or -20 kilojoules mole means what? Out of 2, which is having less negative value, don't go as per the mathematics here. If you go as per the mathematics, minus 10 is more than the minus 50. Okay, but here in terms of chemistry, so less value, less minus is what? It is minus 50. It is minus 50. Sorry, it is minus 10. Sorry, minus 10. So minus 10, minus 50. So 10 is lesser than the 50. So minus 10 is lesser than the minus 50 in terms of chemistry, in terms of electron gain enthalpy. Okay, not in terms of mathematics. So that's why I told in the beginning, don't bring mathematics here. So minus 10, minus 50, if you compare, it is minus 10 which is having less negative electron gain enthalpy. So less negative means what? It is difficulty in adding electron. More negative means what? It is easy to add electron. Minus 50, minus 100, minus 200. So in all these cases, minus is becoming what? The value becoming more, minus 100. So more minus, more negative. So that time we will have easy to add electron. So that's why you want to say negative electron gain enthalpy. What negative? Less electron, less negative electron gain enthalpy. Means maybe minus 10, minus 9, minus 1, or go to positive side, plus 1. Okay. When we will have, when the electronic configuration is stable. Okay. They don't want electron. Now variation along group and variation along the period. Already we learnt this variation where under the ionization enthalpy. Now in the electron gain enthalpy, Eze, electron gain enthalpy, Eze. So what is the variation in the period and in the group? Period is left to right, group is top to bottom, period is horizontal way of arranging the atoms. What is the group? Vertical way of arranging the electrons on the modern periodic table. Okay, right. So all these we have to recall from the modern periodic table. Okay, let us see what is variation along the group. That is from top to bottom. First point is what? From the top to bottom, whether size increases or decreases. That is the main point. The size will increase, no doubt. Sodium 281, potassium 2881, and next one 288, again 1. So size is increasing. Fluorine 27, chlorine 287, next one again last 7. So when you move from top to bottom in a group, size will increase. Okay, extra shell is created, so size will increase. So what is the impact of this increase in the size on the electron gain enthalpy? We will study. Point number 1, electron gain enthalpy becomes less negative as we move down the group. Less negative. Less negative means what? Difficulty in adding. Difficulty in adding. Okay. So as we move from top to bottom, size is becoming more. Attractive force between the nucleus and the outer shell becomes less. So nucleus will not attract with that much force the incoming electron. It will attract, but not what we expect. Therefore, increase in the size when we move from top to bottom, we find less negative value. Okay, so more the negative value, I am repeating once again, easier is the adding electron. Less negative value, difficulty in adding electron. Positive value for electron gain enthalpy, very difficult in adding electron. Okay, right. Now 1 minute wait. Second point. Second point is what? Second point is as we move down the group, the size increases and nuclear charge decreases, due to which the attraction for incoming electron decreases. So as electron gain enthalpy decreases. Same thing I told already. But certain anomalies. So once again, I will remind what we discussed in the earlier sessions. Always we discuss in general. In general. Okay, there are some anomalies. There are some what I can say exception cases will be there. Okay, generally we make best example I give was all metals are solids, but mercury is there. Okay, all metals are maximum solids and gases only, but bromine is there. So like that. So there are some anomalies, but anomalies are there, but we will find out the reason why anomaly like this. So we'll find out. Okay. So what you want to say? But certain anomalies are seen like out of chlorine and fluorine. Fluorine has a less negative electron enthalpy. Oh, chlorine belongs to halogen family. group 17th. So group 17th, what is the electronic configuration? It is a 27 or 287. That means in outermost shell we have 7 electrons. So they are ready to accept electron. All halogens accept electrons. They become anions. They become negative ions, no doubt. So, but though fluorine, chlorine belongs to same group, both are halogens, both are ready to accept electron easily. But why in the case of fluorine, we have less negative value for electron gain enthalpy compared to chlorine? Here we are comparing. Okay, in general we speak that is separate. But when we compare chlorine and fluorine, so where is the fluorine? Fluorine is on the top. Chlorine is next here. If you see the modern periodic table, chlorine is the first member. Chlorine is the second member. So what is the normal trend we see from top to bottom? Okay, when we move, so what size becomes more? Adding is difficulty. Adding is difficulty. Okay, but here in the case of fluorine, chlorine, in the beginning only you are facing adding difficulty. We are not moving from top to bottom in the halogen family. But in the halogen family, for the first member, fluorine, we face problem. Why? It is because fluorine is the smallest in size. Fluorine is where? Fluorine is the second period. From lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay. Then comes the fluorine. So fluorine has got the less atomic size, least, not less, least in that period. Okay, if you move from left to right. So due to the less atomic size, and how many electrons are there? 7 electrons are there. 7 electrons on a small size. Imagine 7 boys in a small room. 7 students, 7 students in bigger room. So, ವಿಲಾಸ ನಾ ಕ್ಲಾಸಲ್ಲಿದ್ದೀನಿ. So 7 boys in one small room. 7 boys or 7 students in a bigger room. So in which case we have more comfortable or more gap in the room where we have the more area. Okay. So in the same way, now imagine that fluorine size is like a small cricket ball. You can imagine like this, just for a comparative purpose. You bring to your mental picture a cricket ball. And on the cricket ball, you imagine 7 electrons, okay, where they are moving on the outer surface. Now you can bring football or the basketball. On that, you imagine the same 7 electrons. Okay. Now, same number of 7 electrons on the cricket ball and the basketball, where they are more congested, they are more close in the case of cricket ball. That means what? That means on the small surface area, okay, small ball, spherical ball, so they are nearby. So when the electrons are nearby, they face inter-electronic repulsions. When they face inter-electronic repulsions, then incoming electron will see already lot of repulsions are facing then for me the difficulty. So we have to supply more energy. That's why it is having what? There is a difficulty in adding electron to the fluorine compared to chlorine. So when we see the electron gain enthalpy value for fluorine and the chlorine, in the case of fluorine, it is less value, less negative value, whereas in the case of chlorine, it is more negative value. So more the negative value I am repeating, more easier is the adding. Less the value of electron gain enthalpy, what a difficulty in adding. Okay, right. Therefore, in the case of fluorine, we face problem due to the small size and inter-electronic repulsions. All reasons are there. Variation along period. Variation along period from left to right. Along period, it increases. The reason being the size decreases and nuclear charge increases. Okay. So when we move from left to right along a period, electron gain enthalpy increases. Why? The reason is what? The size becomes less. Earlier I told in the atomic size trend. So when we move from left to right, electron is entering in the same area, same shell. So thereby either same size or little lesser size due to the attractive force between the nucleus and the outer electron. So due to the less size, small size, So attractive force is more. Okay. So what happens here? Electron gain enthalpy increases. But still, the exceptional behavior is seen. Like electron gain enthalpy of inert gas is positive because we are moving from left right now. So where is the place of inert gases? Extreme right. So though the extreme right, so why they are not having negative electron enthalpy? Again comes what? Stable electronic configuration. So in the case of inert gas, which is a special case, special group, already electrons are fully filled, complete electronic configuration. They don't want. So there is no meaning in adding. Once again, I'm repeating. So electron enthalpy is either less or positive. Please see the values. Please see the values. This is, I think, I have taken from the textbook if I'm not wrong. Okay. So you see, group 1, hydrogen, you leave hydrogen. Hydrogen is some problematic. Helium is problematic. So except hydrogen, helium, we discuss in general. Okay. So lithium, sodium, potassium, rubidium, cesium. Okay. So minus 60, minus 50, minus 48, minus 47, minus 46. So it is becoming less negative. Less negative is what? Less. What is less negative? Larger the negative negative value, more easier is the adding. Okay. So as the size increasing, attractive force is less, so it won't accept electron, but with energy it accepts. But the data says that less negative value as you move from top to in the alkyl metals. Now see the group 16, oxygen family. Okay, oxygen, sulfur, selenium, tellurium, and the polonium. Minus 141, minus 200, minus 195. As we move down, so it is going for the larger negative value for electron gain enthalpy. Larger the value, easier to add. Then why in the first member again small size? Again small size. Okay, right. You see in the fluorine case. Okay, fluorine, chlorine, bromine, iodine, astatine. Okay, minus 328, minus 349. So larger the electron gain enthalpy, larger minus value, plus value. Okay, you see the group 0. Okay, so helium, neon, argon, positive value. Positive value is difficult, very difficult to add. Okay, right.
Sir, doubt, sir.
Please.
The previous page.
Previous slide. Okay.
Sir, here, sir, in fluorine family, sir, halogens.
Ah.
Sir, here it is fluorine is having minus 328, sir.
Hmm.
Chlorine is having 349, sir.
Hmm.
Why chlorine is having more than bromine and iodine also, sir?
Hmm. Anomaly.
Yeah,
Anomaly. Chlorine compared to fluorine, it is bigger in size. Okay. So it is easy to add electron in the case of chlorine compared to fluorine. Fluorine is small in size. So I told already cricket ball and the basketball. So in
Yes,
the
sir,
case of
electron
fluorine,
repulsion.
it is the inter-electronic repulsions. Therefore, slightly difficult. It will accept. No doubt it will
Yes,
accept. No
it is
doubt
not.
it will accept, but not easily compared to chlorine. See here, in 11th and 12th we go for comparative study, not like 10th class. So
But
both are
in
in minus, both are negative value. But when the fluorine is compared to chlorine, size comes into the picture. Okay, so because chlorine is more in size, easy to add. Fluorine is small in size, difficult. Both will accept, no doubt. Okay, right.
sir, but in bromine, sir, bromine is larger than chlorine, sir. Why it will not
Bromine is
accept?
there again D entry. I told you no D entry, F entry. So where is the bromine? Fluorine is in the second period. Chlorine in the third period. So bromine in the fourth period. In the fourth period bromine we have the 3D entry and the F entry is there, no? So they will cover. That is called shielding effect. Hmm? Ah. So as we move down, in the beginning only I told yes, P, D, F. F will have less shielding effect than the D, than the P, than the S. So atomic size factor comes. Okay, inter-electron repulsions comes into the picture, shielding effect comes into the picture. So which effect is playing the role there, that you have to find out. Okay, so it is the combined effect of all the effects. Then they take the decision that whether electron adding is easy or a difficulty. That's why we speak in general. We speak
Yes,
in
sir.
general, but there are some particular cases, there are some anomalies. For the anomaly reasons are there, no? They are there. Okay. So it is because of what? D and F entry. Okay.
Means chlorine is having exact size and shape, sir. So it will,
Definitely, chlorine is the where we do where just entry is the de-entry, so it will not cause
yes,
that much problem. But in the case of bromine, iodine, first class entry of D and F is there, they cause problem. They are the problem creators. Okay, so this we learn in the once again in the what 12th class in detail under the chapter lanthanoid contraction and the actinoid contraction. F contractions are there. Okay.
and again this oxygen in oxygen family also, sir. There also sulfur is having -200, sir.
Easier to add in
And
the
other,
sulfur.
yes, sir, yes, sir.
Again, small
Same,
size.
same.
Ah, same. Whatever you are applying for the fluorine, you apply for the oxygen also. Hmm?
Yes, sir.
Right. Electronegativity. Electronegativity and electron gain therapy both are different. Electron gain oh, it is already my Webex is saying. Okay, we will wind up. So it is saying in 1 minute it will wind up. It is 9:12. I have not seen the timing. Okay, so I think we will wind up in 1 or 2 minutes. So till now, any doubts are there? So you're most welcome. So because I have not now it is flashing Webex. Hmm? Okay, any doubts regarding the today's topic of discussion? Most welcome. Otherwise, automatically it will wind up on its own. So next we will
Sir,
start. Yeah.
sir,
Huh.
sir, you didn't speak about successive electron gain
Is it?
enthalpy.
No, not taken.
Yes,
Uh,
yes,
then that slide you have seen or not? That slide?
no, sir.
No,
Hmm.
no. If I, uh, no. I have taken that arrow mark, big table, red area. I have seen red mark. So taking the fourth electron is very difficult. I told you can take up to one easily. Second, third. Normally, any atom will lose either one or two or three, maximum four. Also difficult. So going for the fifth electron, I5, I7, I6, very difficult. I think I have brought the data also. With the data, it is proved red mark, yellow shade. If it is not shown, then in tomorrow's class, first I'll show that only. Then I'll come to the electron activity. Okay?
Okay, sir.
Right. Okay. Then anything? No problem. Okay, then we'll wind up. Okay. So thank you, my dear students, for being with me today for the very interesting session on trends on modern periodic table. Okay, right.